Lesson 1-3. All right, these have little labels on them as far as identifying the mean and the median. One of them shows a right skew, one shows that a distribution that's symmetric, and the other shows a left skew. Okay, what I want you to see here, and we can play more around with the numbers in class, as far as if you're talking about a measurement of center, and we typically like two of them, means and medians. Okay, mean is like the average, median is like the middle number. Oftentimes we like the median better because we say it's more resistant to a skew. Okay, measures of center get pulled in the direction of the skew. Means always get pulled more. They're much more influential in terms of what the outliers do to it. Okay, they kind of, if it's a left skew, like this one, it drags the mean down more than the median. Okay, the median will likely be affected to some extent, it's just not nearly as much. Okay? So for that right skew, that's why I can tell that if from those points that are labeled, the mean is going to be pulled up more, which is why it's C, whereas the median is B. If it's symmetric, then they're both going to be right in the middle, and they'll be right about the same thing. With the left skew, I can tell it's A for the mean, B for the median, because that mean is going to get pulled down more. This is an activity that we may do in class. I don't have the data for you right now, so we'll have to skip over it. All right, a new data display is that we'll take a look at as a box plot. From box plots, you can tell skews. Okay, these are kind of related to histograms that show the same data. Okay, notice right here on both the histogram and the box plot, you're looking at a right skew. But notice how the center, or the median, is right here. And notice how the right side of that box plot is way more spread out. The last point goes up to the min, or excuse me, that should be on the other side. That should be the max. And your min. Okay? Because your box plot is made off of your 5-number summary. Median, Q1, Q3. There's a calculator tutorial as to how to quickly get that 5-number summary off of your graphing calculator. You should take a look. Okay? This one looks pretty symmetric. A little bit of a left skew. Maybe a little. Same thing here. Little bit of a left. The point being is if you're looking for a skew, a histogram will show it. Box plot will show it pretty well too. You can kind of see the side of the box and the tail that's much, much longer than the other side. That represents a skew. All right. I'm going to show you how to calculate standard deviation, just because I want you to see that one time. It's not something that we very often do. Okay. Now before I do, let's go down to the bottom and fill in all this fun stuff. Okay. I'm going to get all these measurements from your calculator. Again, you should check out, it's the only calculator tutorial that we have in Chapter 1, which is utilizing the edit and the calc feature under statistics. It's how you enter data into a list and get some really basic measurements about the data. Okay? For males, N is always how is your sample size, that was 5. X bar, that's your mean, that was 65.6. This number right here, standard deviation, that's a big one. That tells you the average distance of each point away from the mean. In a minute, we're going to go calculate it. Here's your 5-number summary that box plots are made off of. Okay? The minimum is 29. The median was 56. The maximum was 114. This is data for males. Q3, that's short for first quartile. It is like the median of your bottom half of your data. Okay, so here if you had the data in order, you would take the average of the first two, the minimum and then the second data point. Okay, because you have an even number, so you would just take the mean. But once you got rid of that median, which was 56, again, it's basically the median of the bottom half. Comes out to be 30.5. Q3, it's like the median of the top half. For females, we had 5. Their mean was significantly larger. Okay, so there's your standard deviation. When you see those two numbers compared, you should immediately think the female data is significantly more spread out. Because on average, each piece of data is 98 contacts away from the center, whereas with males it was only 65. Okay? Smaller standard deviation means the data is bunched more closely to the center. 72, median was 89, max of 310, 218.5 for Q3, 80 for Q1. Okay? Again, this right here, you'll hear that referred to as your 5-number summary, and it's how you make a box plot as far as where the tails end, where the box ends, and where the median is marked in the middle. All right, so I'm going to do females here. Actually, males. Take that back. I'm going to do the numbers are a little smaller. All right, so I'm going to show you how you calculate standard deviation. And you're not going to love it, but that's okay, because you're going to wonder as we're doing this, is there a faster way to get it from the calculator? And the answer is yes, and we will typically get it quickly from the calculator. However, this is a small set of data, small enough that we can do this, and I want you to see how this is calculated, because I think it's really good for you to see that. All right, so I'm talking about data for the men. They, on average, had 65.6 contacts. All right? So the first thing you need to do to each piece of data, and that's why standard deviation can be so tedious. And really, if you have a big set of like hundreds of pieces of data, it's very impractical for us to do it by hand. You have to subtract the mean from each piece of data. So I would go through and say, all right, I got to do 29. Take away the mean, and I get negative 36.6. Okay? Same with 114. Take away the mean, and I get 48.4. Okay, each time, what I'm subtracting is this number, negative 9.6. Negative 33.6 and 31.4. Okay? I now have how far away each piece of data is from our center, from our mean. Okay? Now I don't want positives canceling out with negatives, so I'm going to go square them all. So for like right here, I'm going to do negative 36.6 squared, which is 1,339.56. Okay, squaring it gets rid of that negative. All right. So next I square 48.4. I get 2,300. 42.56. Negative 9.6 squared is 92.16. Negative 33.6 squared is that. 31.4 squared is 985.96. Add them all together, and I get 5,889.2. Okay. I divide by the sample size minus 1. Why sample size minus 1? Don't worry about it. Okay. Sometimes we actually do divide by n. Okay. Which would be, in this case, would be 5. So I divide it by 4, and I get 1,472.3. That number, by the way, is important. We don't love it as much as standard deviation, but it's a big deal. It's called the variance. Okay? Now, equation-wise, what we have done so far is we've taken the sum of each piece of data when we took away the mean and squared it. We divide by n minus 1. And remember how we squared everything? Oh yeah, we need to undo that with a square root. And we get 38.4. Okay? Standard deviation is by far our preferred and favorite measure of spread. Okay? When we can get it, we want it. We'll always get it from the calculator. Okay? But I think it's really good for you to see how it works, so you can understand what it measures. The average distance of each point away from the mean. Okay, the mean was 65.6, but on average our 5 pieces of data were 38.4 away from 65. Okay? Remember back with our socks. When we're talking about distributions, we are very interested in how far the data is spread out. Is it all clustered around the center, or is it really spread out? All right, so let's summarize a few things here. Let's talk about spread. Outliers strongly affect the IQR. Actually, I don't think I've even told you that yet, that IQR is interquartile range. You get it from taking the third quartile minus the first. It's like the middle 50%. If you're looking at a box plot, it's the distance from one side of the box to the other. Okay, it doesn't include the tails. But not the standard deviation. The standard deviation is not affected nearly as much. Now, if we want to be really particular with outliers and calculate them mathematically, here's how we do it. Take your third quartile. If you add 1.5 times your interquartile range, it's going to give you a number, and we're going to say anything bigger than that number, let's call it an outlier. On the flip side, if we go all the way down to our first quartile, take away 1.5 times the interquartile range, that'll give you your cutoff for outliers on the bottom. We need 2 cutoffs, right? Because we could have outliers that are really small or really big. Okay? But if we're going to be particular enough to calculate them, that's how we would do it. Okay? That's how we do it. We're talking measures of center. When the graph is skewed, the mean will be pulled in that direction. The median won't change all that much. Okay? So if we have a really strong skew, it's our preference, if we want to make a reference to the center, we'd like to talk about the median, and for spread, we'd like to talk about standard deviation. Okay? If it's symmetric, then the mean and the IQR are fine too, but the mean and the interquartile range will be influenced by outliers pretty significantly. If we're ever talking salary or money, those have kind of the cap at 0, right? So it's hard to have a left skew, but they often don't have limits on the high side, so those are pretty typically skewed to the right. So here's how you could summarize this. If you have symmetric data, feel free to use the mean and the IQR to describe it. If you have a skew, SD is just short for standard deviation, then you want to talk median and standard deviation. Okay? Worth noting, though, if it's symmetric, it's not like median and standard deviation are bad. They'll still work just fine. Okay? Really, the moral of the story here is if you have a skew, you want to stay away from the mean because it's going to be influenced pretty significantly, and the IQR. Thinking conceptually about standard deviation, what would it mean if a standard deviation for a set of data is 0? Would it mean that all the numbers in your set of data are the same? Yes, it would, because the average distance from the mean is 0. All the numbers are in the same place. That question is to just really get you back to thinking about conceptually what standard deviation measures. The average distance of any given point, I should say the average distance of all our points collectively, from 0. How far are they away from the center? Well, here's kind of a fun little one here with some histograms to see if you can identify which data goes with which graph, 1, 2, and 3. Okay? The first thing I notice when I'm looking through this is 1 has a way smaller standard deviation. And I look at how far this data is spread out. It looks like variable number 1 goes from like 0 to 30. 2 goes from negative 15 to 20. So those would have a range of like 30 to 40. Whereas variable 2 only has a range of 5. So right away, I know that first description. I don't even need to look at the mean or the median. The standard deviation is so significantly smaller. That's got to be 2. Okay? That's got to be 2. Now, I can't tell a lot from standard deviation for the other two, for 1 and 3, because they're almost the same. They have a lot more spread than 2. So I already figured that part out. Variable number 1 has a pretty strong right skew. And remember, that skew will influence the mean, and it will pull it so that it's bigger. That gets my attention. Okay? C has measurements where the mean is a lot bigger than the median. That's consistent with a right skew. Variable number 3 looks to be pretty symmetric, so my guess is that its mean and median would be much closer to the same. That's 1. That's 3. Oh goodness, this is just kind of a summary. Mean and IQR, median and standard deviation. Okay, that is a great interpretation of a standard deviation. Okay. The average distance from our individual quiz scores and the mean would be about 1.3 points. Okay, measure spread. The only thing I would add to this is with calculating standard deviation and the 5-number summary. I already mentioned it once. Chapter 1 calculator tutorial. Take a look.